From time to time, your SPX Flow Votator 2 scraped surface heat exchanger requires routine maintenance to ensure peak operating efficiency. This video will teach you the service procedures necessary for replacing the blades, seals, and elastomers, as well as removal, inspection, and replacement of your heat exchanger tube. The attached nameplate provides valuable data regarding the Votator 2 cylinder assembly that can help with obtaining the correct SPX Flow parts. The serial number for the cylinder enables the SPX Flow representative to gain access to the bill of materials so that the appropriate parts are identified and ordered correctly. Servicing your Votator will require the tools displayed here. It is important to use only genuine SPX Flow parts when maintaining this equipment, which has been engineered for precise fit and purpose. Utilizing off-spec components could potentially damage the unit and cause unnecessary downtime. Please refer to the operation manual for further details. It is important to abide by the following safety guidelines prior to performing maintenance on this equipment. Turn off the electrical power and follow all lockout-tagout procedures. Drain the product piping and disconnect from the scrape cylinder assembly. Evacuate the media source from the jacket side for complete disassembly. Special attention must be given to refrigeration sources to ensure refrigerant is pumped out of the scraped surface heat exchanger and piping circuit. Wear proper personal protective equipment, PPE, that meets plant requirements and any applicable health and safety laws and regulations. Consult the product's instruction manual for further details. Remove the two-piece drive and shaft guard over the Mutator shaft by removing the 4 small bolts and nuts and lifting the cover from the top and bottom of the pedestal space. Upon disconnecting the flexible hoses, which include the warm water inlet and outlet connections from the rotary joint, remove the rotary joint by placing an open-end wrench on the flat shoulder and loosen from the shaft lock nut by turning clockwise. Slide the rotary joint and the shaft heater pipe assembly from the Mutator shaft. Tap the Plastic Locknut Safety cover with a rubber mallet at the 12 o'clock position to disengage it from the stainless steel bearing retainer. Loosen the bolt nut and washer from the sanitary hinged clamp and remove. Next, remove the safety cover bearing retainer from the non-driven head. Remove the shaft lock nut, which has left-hand threads, by utilizing the shaft lock nut wrench and mallet. Engage the shaft lock nut wrench, which is part number 79-2, onto the shaft lock nut, and wrap the end of the wrench once or twice to loosen. Cup your hand at the bottom of the shaft lock nut as the nut is being removed to avoid dropping and damaging the fine left-hand threads. When the rotary joint is utilized, the heater pipe support should be removed. Insert your index finger into the open end of the non-drive end of the Mutator shaft and slide the heater pipe support from the shaft. Loosen the wing acorn nut to allow the V2 locking latch to swing clockwise to the 2 o'clock position. Wedge a rag between the V2 locking latch and stainless steel front cover to temporarily position the latch. Next, rotate the non-drive end head in a clockwise direction until the mating lugs are disengaged. Insert the head removal tool, or HRT, through the bearing and into the threaded end of the Mutator shaft. Slide the non-driven end head along the length of the HRT until the stationary seal face is past the end of the Mutator shaft. Grasp the end of the HRT with the non-drive end head and remove it from the Mutator shaft. Carry it to a table or other stable work surface for further maintenance. Please exercise caution during this procedure, as failing to use the head removal tool can result in damage to the seal face. Use of the tool prevents chipping the stationary seal face on the end of the shaft during removal or replacement of the head. Loosen the bolts, nuts, and washers from the two-piece sanitary clamp and remove. Next, remove the safety cover bearing retainer from the non-driven extra heavy-duty head. Remove the shaft lock nut, which has left-hand threads, by utilizing the shaft lock nut wrench and mallet. Engage the shaft lock nut wrench onto the shaft lock nut and wrap the end of the wrench once or twice to loosen. Cup your hand at the bottom of the shaft lock nut as the nut is being removed to avoid dropping and damaging the fine left-hand threads. Loosen the wing nut to allow the V2 locking latch to swing clockwise to a 2 o'clock position. Wedge a rag between the V2 locking latch and stainless steel front cover to temporarily position the latch. Next, rotate the non-drive end extra heavy-duty head in a clockwise direction until the mating lugs are disengaged. Insert the head removal tool through the bearing and into the threaded end of the mutator shaft. Then, slide the non-driven end extra heavy-duty head along the length of the tool until the stationary seal face is past the end of the mutator shaft. Grasp the end of the tool along with the head and remove the tool from the mutator shaft. Carry it to a table or other stable work surface for further maintenance if needed. Please exercise caution during this procedure, as failing to use the head removal tool can result in damage to the seal face. Use of the tool prevents chipping the stationary seal face on the end of the shaft during removal or replacement of the head. Insert the plastic shaft skid into the unit by first installing it at the top 12 o'clock position. Rotate the shaft skid clockwise while lifting slightly on the mutator shaft and position the shaft skid at 6 o'clock location. This ensures the tube is protected from scratching and chipping of the smooth tube surface. Remove the shaft and skid together from the cylinder assembly and place them on a table or cradle. This activity should include 2 persons based on the weight of the mutator shaft. Failing to use the plastic shaft skid in the procedure can result in scratching, scoring, or chipping of the inner wall surface of the product tube during removal or replacement of the mutator shaft. Remove the product head on the drive end by rotating it clockwise when viewed from driven end to disengage it from the locking lugs. The drive end head must be extracted from the top or bottom of the pedestal once it has been disengaged from the cylinder. Place the head on a table or other stable work surface for maintenance. Inspect the product tube inner surface visually after the head and shaft have been removed. First, visually inspect the tube inner surface with a flashlight directed down the length of the tube from both the non-drive and the driven ends of the cylinder assembly. Another tube inspection technique is to reach into the tube at both non-drive and drive ends with your arm and run your fingernail down the length of the tube at the 12, 3, 6, and 9 o'clock positions to determine the severity of a groove. If your fingernail gets hung up in a groove, the tube should be carefully monitored and sent to SPX Flow for a formal inspection and disposition. The tube should have a smooth surface finish. If you observe scoring, gouging, and roughness, then replacement or refurbishment by SPX Flow can be considered and/or arranged. When the surface of the plating is damaged or worn through from chipping or flaking, it may be re-chromed to original specifications by SPX Flow. For stainless tubes without chroming, inspect the tube surface for shallow score marks, gouges, or roughness. Minimal wear previously described can be taken out by honing the tube and then polishing. The grooving condition will only get worse over time, so frequent inspections will detect potential issues that can be addressed right away. Check to ensure that all supply lines to the unit are closed, locked, and tagged out, and make sure that the entire unit is purged of fluids. Remove the heads and shaft as described earlier. Remove locking latch and hardware holding the front cover. Remove 8 3/8" bolts that hold the removable tube to the jacket. Take 4 jack bolts and thread into the B-holes. The B-holes are located at the 12, 3, 6, and 9 o'clock locations. Do not tighten. Using an X pattern, gradually tighten the bolts to withdraw the tube from the jacket. Considerable effort may be needed to overcome any stickiness. Once the jacket side double O-rings are visible, the jack bolts can be removed. Pull the tube out of the jacket assembly from the non-driven end. It is recommended to have another person holding the inside of the product tube from the drive end during the initial removal process, and then again upon final tube withdrawal. Also, consider marking the tube and jacket so that the tube can be reinstalled in the same jacket and not inadvertently installed into another Votator cylinder assembly. If the tube does not start to pull away from the jacket as the bolts are tightened, stop and make sure the product head on the drive end is removed. Place a block of wood across the drive end of the tube and apply pressure to force the tube opposite the drive end. When the tube is loose, use the bolts to complete the removal process. If the tube cannot be removed, contact an SPX Flow service representative. Remove non-drive and drive end O-rings and clean the O-ring grooves on the outer diameter of the product tube prior to installing new jacket side O-rings. Lubricate and install new jacket side O-rings on the product tube. Different size O-rings on non-drive versus drive ends. Next, wipe down the exterior of the product tube to remove any scale or buildup. If the product tube is a BWS version, make sure to replace the packing gland. See Votator 2 O&M Manual. Inspect the jacket cylinder interior and wipe out all dirt and impurities. If O-ring sealing surfaces on the jacket cylinder are coated with debris, clean with a Scotch-Brite pad along the perimeter. Then lubricate O-ring sealing surfaces inside the jacket. Insert the product tube into the jacket cylinder from the non-drive end. The support pins on the heat tube should be at the 5 o'clock and 7 o'clock positions during installation. Push the product tube into the cylinder slowly with assistance on the drive end to guide the tube into place to avoid cutting the jacket side O-rings. Insert 2 jack bolts 180 degrees apart and thread them into the bolt holes designated for the 3/8 inch bolts. Tighten these jacket bolts so that the last jacket side O-ring is partially seated and remove both jacket bolts. Thread the 8 3/8 inch bolts prepped with never seize through the flange of the heat exchanger tube into the jacket cylinder. Tighten all bolts in a crossing pattern until the tube is snugged down to the jacket cylinder. Use a torque wrench to tighten all bolts to 240 inch-pounds over 20 foot-pounds of torque. Install the front cover with the drain hole slot at the 6 o'clock position. Apply anti-seize to the 3 bolts used to secure the front cover and attach the latch hardware. Tighten all 3 bolts to secure the front stainless steel cover. Remove the outboard bearing from the non-drive end head and verify the position of the lubrication ring is aligned with the grease fitting on the exterior of the non-drive end head. Additionally, check the inner bearing race for discoloration, play, and smooth movement. Use a suitable nlgi Grade 2 bearing grease for the shaft bearing. Do not over-lubricate, as an excessively packed bearing will overheat and fail prematurely. Frequency of lubrication is dependent on the environment. Lubricate daily if it comes in contact with water or steam. Otherwise, lubricate on a weekly basis. The drive end head does not have a bearing. Warning: Never immerse the front mutator shaft bearing in cleaning solution or subject it to steam. Clean the bearing with a dry cloth and lubricate. Inspection of the bearing should be ongoing. If looseness is detected, replace the bearing immediately. Worn-out bearings can cause shaft misalignment that will cause the mechanical seals and gearbox to wear out prematurely. Keep all shaft surfaces smooth and clean, especially in seal and bearing areas. Take special care while cleaning and maintaining the bearing and seals to ensure that these areas of the shaft are not scratched or damaged. A bent or imbalanced shaft will cause premature bearing, seal, and blade wear and may damage tube walls. Check the shafts annually for straightness and balance. Next, remove the product head O-ring and inspect for cuts, abrasions, and elasticity. Clean and lubricate the product head O-ring groove before installing the new O-ring. Finally, the stationary seals for both the non-drive and drive-end head should be removed to ensure the seal face and O-rings are replaced if necessary. To remove the stationary seal components, the small diameter end of the seal installation and removal tool can be utilized. Lay the seal tool with the small diameter end facing upward on a steady surface and lower the non-drive end and drive end heads down onto the tool and push firmly on the head to dislodge the stationary single or double mechanical seal components from the head bore. Remove, inspect, and replace both O-rings held in the stationary single mechanical stainless steel seal seat, seal head insert, and, when applicable, the double mechanical stationary seal ring. Before reinstalling the stationary seal component, clean the product head O-ring groove and stationary seal bore thoroughly. Lubricate the outer circumference of the stainless steel seal seat, O-ring, and head bore. Align the anti-rotational pin located on the bottom side of the stainless steel seal seat to the adjoining pin slot located in the bottom of the head cavity. Then insert the seal into the head up to the O-ring. Utilize the large diameter end of the seal installation and removal tool and align the tool slots with the seal seat. Next, position the paddle into the tool groove on the small diameter end and position the larger paddle ends between the head locking lugs. Position your hands above and rest them on either side of the paddle and push firmly into the head cavity. Inspect the margin between the seat seal and head bore to ensure the anti-rotational pin is seated in the pin slot. Remove the paddle and twist the seat installation and removal tool to seat the anti-rotational pin if it is misaligned. Again, check the margin gap to verify the pin is properly seated. Finally, insert the stationary seal head insert up to the O-rings in the head cavity and align the lugs on the seal seat adjustment lugs. Once alignment is verified, insert the large diameter end of the seal installation and removal tool into the seal head insert with the paddle in the groove. Again, position your hands above and rest them on either side of the paddle and push firmly into the seal. Remove the tool and paddle and verify the seal seat and seal head insert are properly seated together. If a double mechanical seal is present, the stationary seal ring should be positioned on the inside diameter of the stainless steel seal seat. Insert the small diameter end of the seal installation and removal tool onto the double mechanical seal ring with the paddle in the groove and push firmly into position. This maintenance activity is the same procedure for both the drive and non-drive end heads. Next, prepare the product head O-ring by lightly stretching and lubricating it with a standard food-grade lubricant. Insert it into the product head O-ring groove and add several small dollops of food-grade grease around the perimeter to secure the O-ring during the head installation onto the cylinder. Position the non-drive end head with the bearing cavity facing upwards so the front-end bearing can be reinstalled. Align the lubrication ring to the grease fitting and insert the bearing. The non-drive end extra heavy-duty head is also positioned with the bearing cavity facing upward to accept the Sealed for Life bearing installation. This completes the removal, inspection, and assembly of the components that are internal to the non-drive end and drive end heads for both the single and double mechanical seal arrangements. Remove the rotary seal components from the mutator shaft on both ends for inspection. The seal keeper O-ring is usually removed first to release the rotary seal assemblies from their positions on both ends of the mutator shaft. For the 2012 seal design, it's often easier to remove the rotating seal seat from the rotary seal body before removing the keeper O-ring. While wearing a protective glove, place the open end of the spring on the outside edge of the seal drive pen located on the mutator shaft. Unwind the wavy spring until the entire spring is free from the seal drive pen. Now that the rotary seals are removed from the mutator shaft, a careful examination of the rotary seal assemblies and wavy spring should be conducted before reassembly. All shaft surfaces should be smooth and clean, especially in the seal and bearing areas. The non-drive end bearing can be tested to fit on the stub end to make sure it can easily glide when reassembly takes place. Take special care to ensure that these areas of the shaft are not scratched or damaged. A bent or imbalanced shaft can cause premature bearing, seal, and blade wear, and may damage tube walls. Check the shafts annually for straightness and balance. The mutator shaft drive spline end should be inspected to ensure the splines are free of burrs and unusual buildup. The white bullet guide should be securely in position with Loctite on the bolt threads. If not, remove the white bullet by unscrewing from the drive end stub shaft. Notice the SPX flow part number is stamped on the end of the mutator shaft for easy identification. After removing the bullet, apply Loctite 243 to the bullet threads and then screw it back into the internal thread on the drive end of the mutator shaft. The non-driven end of the mutator shaft has a stub end with fine internal threads that are left-handed. With the shaft removed for general inspection, lightly apply anti-seize to the Locknut threads. The drive end shaft stub should be cleaned with a Scotch-Brite pad to remove any buildup, and then wiped with a rag to remove loosened debris. Thread into the internal threads on the non-drive end of the shaft. The lock nut should easily thread into the stub end during the installation process. If there is some unusual resistance, the threads may have a burr or some amount of cross-threading. If the lock nut cannot be fully threaded, a tap may be required to clean the left-handed threads for proper shaft lock nut engagement. Repeat the process of threading the lock nut into the newly dressed internal shaft threads to ensure proper threading is accomplished. Remove the lock nut before the non-drive end head is installed. The mutator shaft also has press-fit drive seal pens on both ends of the shaft that are important to the functionality of the seals. These pens must be present and possess the proper shape and height. The primary seal drive pens are 180 degrees apart and designed for the primary rotating seal body to turn within the mutator shaft. These primary seal drive pens must be round in shape and 5/32 plus or minus 15 thousandths of an inch tall, measured above the stub shaft surface. The secondary seal drive pens for the double mechanical option with one on each end of the mutator shaft should be 3/32 plus or minus 15 thousandths of an inch above the stub shaft surface. It is extremely important that these dimensions are maintained. If the pens are too high, the seal will jam. If they are too low, the body will rotate. Additionally, when the pins are missing or their shape becomes altered, they should be replaced immediately. Apply anti-seize compound on the male splines and the next 2 inches of the stub shaft before installing. Inspect the rotary seal faces to identify any defects that would impact the integrity of the seal once in operation. Additionally, inspect the stainless steel seal body for any damage or missing drive pens. Inspect, replace, and lightly lubricate the two O-rings in the inner and outer locations on the stainless steel seal body. The inner O-ring must be stretched to accurately fit the inner O-ring groove and maintain a proper seal on the shaft body. Finally, inspect the wavy spring and confirm the general shape is correct. Compare it to a new wavy spring to determine whether the height is correct. Over-compressed wavy springs will not create the necessary seal face pressure between the stationary and rotary components after reassembly, and thus may potentially leak. Reinstall the spring while wearing gloves to protect against sharp edges. Open the end of the spring and place it behind the seal drive pin located on the mutator shaft. Wind the wavy spring until the entire spring is behind the seal drive pin. Align the rotary seal with the 3 adjacent seal pins located on the perimeter of the rotary seal body and press into position over the outer seal body O-ring. For the one-piece seal design, the inner O-ring must be stretched, lightly lubricated, and fitted onto the seal body. With the rotary seal now ready for installation, slide it onto the mutator shaft for final positioning. Align the seal drive pins on the mutator shaft to the open notches of the rotary seal body and push the rotary seal body into position. Next, apply enough pressure to slightly compress the wavy spring and install the seal keeper O-ring into place. To ensure the seal is properly installed, grab the outer seal body assembly and rotate it to the right and left until the seal pins are touched. You will hear a knock as the pin comes into contact with the rotary seal body. Finally, push the seal body to ensure it moves freely with the wavy spring and with respect to the mutator shaft. Complete the rotary seal assembly on both ends of the mutator shaft. For the two-piece seal design, the seal body insert must be fitted with an O-ring on the inner diameter. This O-ring will need to be slightly stretched before it's positioned. Additionally, the seal body must be fitted with 2 O-rings. The outer seal body insert O-ring will need to be stretched and positioned in the outer edge of the seal insert groove. Next, the seal body insert is pushed firmly into position. Finally, the seal body inner ID O-ring must also be stretched and lightly lubricated before installing. Now that the two-piece rotary seal is ready for installation, slide it onto the mutator shaft for final positioning. Align the seal drive pins on the mutator shaft to the open notches of the rotary seal body and push the rotary seal body into position. Next, apply enough pressure to slightly compress the wavy spring and install the seal keeper O-ring into place. To ensure the seal is properly installed, grab the outer seal body assembly and rotate it to the right and left until the seal pins are touched. You will hear a knock as the pin comes into contact with the rotary seal body. Finally, push the seal body to ensure it moves freely with the wavy spring and with respect to the mutator shaft. Complete the rotary seal assembly on both ends of the mutator shaft. The rotary seal items that make up the double mechanical seal are commonly referred to as secondary components, which include a spring, seal body, seal face, and O-rings. The seal body should be inspected for general wear on the inside and outside diameters. The inner and outer O-ring should be inspected and replaced if burrs, cuts, or flattening is apparent. The secondary rotary seal insert face should be inspected and replaced if necessary. Lightly apply lubricant to the inner O-ring and insert it into the inside diameter of the secondary seal body groove. When this seal insert is replaced, the corresponding outer O-ring should be replaced to ensure a tight fit. The seal insert should not spin inside the secondary seal body during operation, so do not lubricate this O-ring. Insert the outer O-ring into the secondary seal body and press the seal insert evenly with both hands until it bottoms out. Just as with the wavy spring in the primary seal, the secondary wavy spring should be inspected for shape and size when compared to a new spring. Slide the spring into place over the secondary seal pin only after the primary seal has been reinstalled. It's a loose-fitting item due to the design. Finally, slide the secondary rotary seal body assembly onto the mutator shaft. Align the pin slot on this component with the secondary drive pin on the mutator shaft and position the seal body assembly through the inside diameter of the secondary wavy spring. Complete the secondary rotary seal assembly on both ends of the mutator shaft. SPX Flow offers other blade styles that are application-specific and address various product and process conditions. The two basic types are closed and open. Closed blades are considered a standard blade and are solid without holes or cutouts. The open styles consist of either holes along the length of the blade or cutaways at the back edge around the blade pin slots. Blade materials range from stainless steel, brass, and plastic such as Celcon, PEEK, and metal detectable PEEK. The scraper blades are removed by lifting up and pulling them from the pins. Plastic blades with the locking feature should be lifted upward and then slid to the right before removing them from the blade pin. Reverse this procedure for reinstallation, and make sure the beveled edge is installed toward the shaft. The blade pen holders should be inspected for unusual wear on the pen tops and slots. Abrasions to the top of the blade pens could indicate contact with the tube wall, so there may be adjacent tube damage as well, and may indicate the shaft is bent. Blade pen slots should be round and uniform in shape, thus indicating the blades are free to float and move through each revolution of the shaft. Irregular shape or roundness to the blade pen slot indicates the blade tip pressures at the wall are high, thus exerting excessive forces through the blade and into the blade pin slot. Preventative measures on the process side should be addressed to minimize the tip pressures so that potential damage to the blade pins does not become widespread. A relieved blade with holes is often used for viscous product that would otherwise result in high amperage conditions with a closed style. The series of holes allows the product to flow through the blade, but still maintains its scraping action with reduced power requirements and high blade tip pressures. The cutaway style relieved blade helps prevent sticky or crystallizing products from building up on the blade and restricting its floating action in the universal blade pens. Restrictions caused by product buildup can cause excessive tube and blade wear, and in some cases cause severe damage. Note: keep the blades in the same position on the mutator shaft throughout the life of the blade. Make sure the blades are removed and installed in the same location on the shaft. A flat surface called the heel and a burr or feathered edge develops at the contact area on the side of the blade that is against the tube wall. The blades must be maintained to achieve maximum performance. When the heel of the universal blade, which is 2 inches wide by 6 inches long, reaches a maximum of 1/16 inch or 1.6 millimeters on metal blades, or 1/8 inch or 3.2 millimeters on plastic blades, they must be replaced or resharpened. Some of the 6-inch plastic blades have an SPX logo on the back edge that can be used as a minimum wear indicator. Resharpening these blades can occur up to the top edge of the SPX logo. For mutator shafts that are 4.5 inches in diameter or larger, the blade should not be sharpened to a blade width of less than 1 3/8 inches. For mutator shafts that are 4 inches in diameter, the blade should not be sharpened to a blade width of less than 1 1/2 inches. Stainless steel blades for the 5 1/4 inch mutator shafts are 1 9/16 by 23 29/32 of an inch. The minimum width after sharpening is 1 3/8 inch, and the sharpening angle is at a 15-degree angle. Worn blades reduce heat transfer efficiency and can cause excessive wear on the product tube walls. Blades can be subjected to challenging products and processes that not only wear the scraping edge but show evidence of warping, cracking, pen slot damage, or destruction. As the blades wear across the interior of the heat exchanger tube, they wear into the contour of the tube. Each blade should be inspected for wear and signs of fatigue or cracking at the blade pin location and should be replaced if damage has occurred. Failure to replace damaged blades may result in future breakage, which can damage other blades or the heat transfer tube and result in blade particles in the product. Additionally, unscraped portions of the product tube surface will reduce the thermal efficiency and may be difficult to clean with normal CIP procedures. Caution: high concentrations of acid or caustic should be avoided if plastic scraper blades are used. Cleaners should be compatible with the elastomers in the heat exchanger. Reinstall the drive end head either from the top or bottom openings of the drive pedestal. Lock the drive end head into position with the correct product port orientation in either the 12 or 6 o'clock position. With the mutator shaft still sitting in the shaft removal skid, insert them together into the non-drive end of the heat exchanger and slowly push the mutator shaft through the drive end head and into the gear reducer. As the mutator shaft spline is entering into the hollow bore shaft of the gear reducer, rotate the shaft slightly to allow the spline to align it to the mating splines in the gear reducer. It's important not to slam the mutator shaft into position, or damage to the drive end seal faces could occur. The last scraper blade on the non-drive end should be flush with the end of the product tube. At this point, remove the shaft skid by lifting up on the mutator shaft on the non-drive end and rotate the shaft skid to the 12 o'clock position and remove it from the cylinder. Insert the head removal tool through the head, bearing, and into the threaded end of the mutator shaft. Then, slide the non-drive end head over the tool and up onto the stub end of the mutator shaft. Position the head to accept the mating product tube locking lugs. Once the head is engaged on the product tube, rotate the head and position the product head connection. Remove the head tool and rag. Then, swing the bayonet locking arm into position and tighten down the wing nut. Insert the head removal tool through the extra heavy-duty head, bearing, and into the threaded end of the mutator shaft. Slide the non-drive end head over the tool and up onto the stub end of the mutator shaft. Position the head to accept the mating product tube locking lugs. Once the head is engaged on the product tube, rotate the head and position the product head connection. Remove the head removal tool and rag, then swing the bayonet locking arm into position and tighten down the wing nut. When the rotary joint option is required, insert the heater pipe support on the non-drive end and through the hollow mutator shaft. Attach the left-hand threaded lock nut onto the mutator shaft by hand. If the rotary joint option is required, place the O-ring onto the threaded end of the shaft lock nut. Once the lock nut cannot be turned by hand, utilize the lock nut wrench and strike once or twice to lock down. Do not over-tighten or you run the risk of damaging the threads. Install the bearing retainer and nut guard assembly, also known as the front safety cover, onto the non-driven end head by positioning the sanitary hinged clamp, inserting the bolt, washer, and nut. Install the extra heavy-duty bearing retainer and nut guard assembly, also known as the front safety cover, onto the non-driven end extra heavy-duty head by positioning the two-piece sanitary clamp and inserting the bolts, washers, and nuts. Insert the rotary joint and shaft heater pipe assembly through the shaft lock nut with the green flat gasket. Place an open-end wrench on the flat shoulder and tighten into the shaft lock nut in a countercurrent direction. Install the two-piece driver and shaft guard over the mutator shaft by positioning the covers from the top and bottom of the pedestal space and tightening the 4 small bolts and nuts. Locate the oil drain port plug, place a bucket under the port to catch oil, and begin loosening the oil drain plug. Drain oil from the gearbox and collect into a bucket for appropriate disposal. Once the oil has completely drained, replace the oil drain plug with the gasket and tighten. Go to the top of the gearbox and locate the vent port. Loosen the vent plug. Place a funnel in the port opening and fill the gearbox with Mobile SHC Cybus 220. Simultaneously locate the oil level plug on the front face to ensure oil level is 15/100 inch, 4 mm below the oil level hole. Replace the vent plug and tighten. Following these procedures will help you properly maintain your SPX Flow Waukesha Cherry Burrell Votator Scraped Surface Heat Exchanger to maximize operating life and maintain process integrity. To order genuine replacement parts or tools, contact your authorized SPX Flow sales representative or visit www.spxflow.com/WCB for more information.